After introducing the development of NB-IoT and the reasons why operators choose this technology, let's take a look at the key technologies and the features of NB-IoT. This is the most important part of this course. I will explain the features of NB-IoT and the working principles behind these features. First, I will talk about the key technologies of NB-IoT at the physical layer. NB-IoT stands for Narrowband Internet of Things. Why do we say narrowband? Its system bandwidth is just 180 kHz, which is even smaller than the 4G guard bandwidth. As we just mentioned, NB-IoT networks are based on 4G networks. NB-IoT uses the same OFDMA and SCFDMA techniques for uplink and downlink multiplexing. Although NB-IoT is based on 4G LTE, NB-IoT is designed for a much lower data rate and to run much less bandwidth than a 4G network. Many of parts of the 4G network have been stripped out for NB-IoT. For example, NB-IoT has only 2 physical channels and 1 signal in the uplink, and 3 physical channels and 2 signals in the downlink. You do not need to remember the name of these channels or signals. Just remember the main point, which is to achieve wider coverage with less power and for less money. Next, I will introduce 4 key features of NB-IoT: ultra low cost, ultra low power consumption, ultra wide coverage, and massive connections. First, the ultra low cost. NB-IoT can be directly deployed on existing operator networks to save money. How do operators deploy NB-IoT? There are 3 deployment modes. The first is standalone deployment, which means that NB-IoT does not rely on existing LTE networks. Instead, GSM frequency bands are refarmed. The channel bandwidth of GSM is 200 kHz, which is more than enough for the 180 kHz needed for NB-IoT. The second is guard band deployment. NB-IoT can be deployed on the guard band of the existing 4G frequency band, taking advantage of existing idle resources. The third is in-band deployment, where NB-IoT is directly deployed in the 4G frequency band. In a 4G network, the frequency and time domains are divided into small resource blocks. NB-IoT is designed to be fully compatible with 4G. The bandwidth of each small resource block in 4G is 180 kHz. That is why the system bandwidth of NB-IoT was designed to be 180 kHz. Regardless of what deployment mode is used, NB-IoT does not depend on signal resources of any system. This is one of the reasons for the ultra-low costs. The ultra-low cost is also partly thanks to some functions in the chip design being simplified. Huawei has rolled out Botica 150 chips dedicated for the IoT through single antenna, FDD half duplex, and the like. For NB-IoT, single antenna and FDD half duplex are enough. This simplified design reduces the cost of NB-IoT modules. Next, let's talk about another NB-IoT feature: ultra-low power consumption. NB-IoT supports eDRX and PSM. Discontinuous reception, which is DRX, is a paging mode used by many mobile phones. What type of paging should the mobile phone use to ensure that messages can be monitored in real time? Does that mean the mobile phone has to be waiting to be paged all the time, like a student in class waiting for the teacher to call on them? However, this waiting uses a lot of power. DRX addresses this issue. So how does DRX work? as you can see, the blue path in the figure is indicating that the mobile phone is being paged. After each paging message is received, the mobile phone enters the idle state and disables the receiver, like a student taking brief a nap in class. In DRX mode, the interval between each paging is called a DRX period, which can be 1.28 seconds and 2.56 seconds, 5.12 seconds, and 10.24 seconds. DRX still uses too much power for IoT devices. Even if you only make calls or send SMS messages on the mobile phone, you still need to charge once every day in most cases, or at least every couple of days. IoT devices need to last several years or even more than a decade on a single charge. That's why we developed eDRX based on DRX. eDRX introduced a paging time window, which is PTW. Within each PTW, an IoT device makes 3 paging attempts. At the same interval as the DRX period, after these 3 paging attempts, the device enters sleep mode for a long time. This period is called an eDRX period. An eDRX period can be up to 2.92 hours. Operators can set the eDRX cycle based on the actual situation of IoT devices and the required data. However, even eDRX does not save enough power for some IoT devices, which is why PSM was introduced. With PSM, the sleep period can be up to 310 hours, or about 13 days. With PSM, if the service platform at the application layer delivers commands to a device, the device will not receive these commands immediately. These commands are temporarily stored on the IoT platform and will be issued after the device wakes up from sleep mode. You can see that these 3 modes correspond to different scenario requirements of IoT. For example, DRX is good for shared bicycle because we don't want to wait for as long as 5 minutes before a bicycle automatically unlocks. A 5 minutes waiting duration is required if eDRX is used. But eDRX is fine for scenarios such as logistics monitoring, because goods do not need to be monitored in real time during transport. You only need to check their location at a certain interval. PSM is good for water or electricity meters, since we only need to check the data on these devices about twice a month. NB-IoT low power consumption modes are closely related to the scenarios. Now, let's look at the ultra-wide coverage. What is the design objective of NB-IoT in terms of coverage? NB-IoT provides 20 dB better coverage than GPRS. As you can see, that is 3 times as much coverage, and that is why NB-IoT signals can penetrate through physical opticals better too. How does NB-IoT expand its coverage? In downlink, NB-IoT enhances the transmission reliability through repeated retransmission for more gain. In the uplink, NB-IoT also increases the gain through repeated transmission, just like it does in the downlink. In addition, NB-IoT uses a single subcarrier for transmission, a 15 kHz subcarrier. This is different from that of 4G. In 4G, 180 kHz is required at least for every transmission. So for any given amount of transmission power, you get better gain with narrowband. This is one of the reasons why NB-IoT can provide such wide coverage. The last feature is massive connectivity. What is the difference between the traffic model of IoT devices and that of mobile phones. IoT devices are vastly more numerous, but each device sends only very small data packets, and the latency is generally not a serious issue. To ensure the communications quality for all users, a base station can only serve a limited number of users. IoT devices do not require especially high-quality communications, so more devices can be connected to the same base station. A single base station can handle up to 50,000 devices, partly because many of them are in the dormant state. That's all for the introduction to key NB-IoT features and their working principles. Now, let's briefly summarize the key features that we have just gone over. First, the cost of an NB-IoT module can be reduced to approximately $5, about 30 to 40 yuan. Through a series of simplifications, its ultra-low power consumption means that the battery can last over a decade. And finally, NB-IoT has a 20 dB gain, which means excellent coverage, and up to 50,000 devices can be connected to a single base station. That's it for the NB-IoT features. Now, let's take a look at the NB-IoT networks dedicated to devices. What are the applications of NB-IoT in our daily lives? First, let's talk about the overall architecture of the NB-IoT solution. This architecture can be associated with the IoT architecture we mentioned earlier. NB-IoT devices are deployed at the sensing layer, and NB-IoT base stations are at the network layer, and the IoT platform is at the platform layer, and a variety of applications are provided at the application layer. Let's now take a look at some NB-IoT applications from the perspective of the overall architecture of this solution. The first case we are going to talk about is smart parking. We talked about smart parking in the previous course too. Broadly speaking, there are two main types of parking: roadside parking and indoors parking. Roadside or indoor, there are all sorts of issues. For example, it is difficult to locate parking spots due to poor signal. The price of vehicle detectors is driven up by the expensive communications modules they require, and they require a lot of electricity to keep running. NB-IoT eliminates the need for these expensive communication modules. These NB-IoT modules and base stations can also be used for a range of other applications as well. With NB-IoT, all of the devices in the entire city can be connected to the same network for easier maintenance and management. Thanks to the low power consumption of NB-IoT, the device batteries last a long time. The next use case is shared bikes. Before NB-IoT locks were introduced, bike sharing relied on mechanical locks and GPRS electronic lock. These two types of locks are not easy to use. Mechanical locks rely on static passwords are used. A bicycle can be used by anyone who knows the password. This is also true for GPRS electronic locks, which are expensive and difficult to build for use, resulting in poor user experience. To achieve low power consumption and reduce costs, we use NB-IoT for communications. We can also find NB-IoT applications in smart street lamps and smart meter readings. Similar to the previous two cases, NB-IoT reduces the cost of solutions, improves use efficiency, and unifies management for enterprises or companies. That's all for the NB-IoT solution. Now, let's briefly summarize. In this course, we learned about NB-IoT technologies in LPWA scenarios. I briefly covered the NB-IoT development history and the development of the NB-IoT industry. And we looked at the key technologies and solutions of NB-IoT. That's all for this course. In the next course, we will learn about the most popular cellular communications technology, 5G, including its key technologies, features, and solutions. Thank you for your watching. See you next time.